Good morning, Year 4. I hope you're well. Welcome to today's maths lesson. In today's lesson, you're going to be calculating fractions of a quantity, and I'll explain what that means in a little while. But before that, you have your daily fluency questions, please. Can you pause the video and spend 3 minutes? Write down the answers on your page. Off you go. Okay, then calculate 3/8 of 32, but we can work out 1/8 is 4, so 3/8 is 12. Find the difference between 3/7 and 1. Well, we know that in this circumstance, 1 whole would be 7/7, so the difference would be 4/7. And finally, what fraction of the shape is shaded? It is 5/9 because 5 squares are orange, but all the squares, there are 9 altogether. Okay then, can you get ready for today's learning by answering these questions, please? Pause the video, have a go. Okay, so 1/3 of 93, we know that our denominator is 3. We are splitting our bar model into 3. Our whole is worth 93, and we could use a variety of methods such as base 10 or place value counters to work out that 1/3 is 31. 1/4 of 56 then, well, you know that you are looking for 1 out of the 4 in your bar model. You can use your place value counters to help you. Put 110 in each of the boxes. You've got 110 remaining. You can exchange that 110 for 10 ones, giving you 14 ones, and then you can pop them in there. Okay, finally then, 16 ones, and you can pop them in there. Finally then, 3/4 of 16. We know that we're dividing 16 by 4 first of all, and then we are working out what 1 is, which is 4, and then 3/4 would be 12. Well done if you got all those right. Okay, so today we're looking at fractions of a quantity. So what we want to do is we want to find out half of 80, 1/4 of 80, and 1/8 of 80. So what we're going to do is we're going to use our bar model to help us, and we can see that 1/2 of 80 is 2 parts. Well, 1/2 of 80 is 40. 1/4 of 80 would be 4 parts, and we can work out that 80 divided by 4 is 20. And then 1/8 of 80, we can see that we are looking at 1 part, and that is 10. Now, I want you to think, what do you notice about the following fractions, the whole number, and the answer? Between the three of them, I tried to cover it with my hand then, thinking that we're in school, ignore the bar models for now. Think about the fraction, the whole number, and the answer. What's the same between the three of them, and what's changed? Pause the video and have a think. Okay, so you might have noticed that the whole number stays the same for each of these fractions. We are always looking at the same whole number. However, my denominator changes each time. What is the relationship between 2 and 4? What do I need to multiply by to get 4? That's right, I need to multiply it by 2. But what do you notice about our answers? How do we get from 40 to 20? That's right, we divide by 2. So it just so happens that when our denominator changes, but our whole number stays the same, whatever we multiply the denominator by to get to this one, you divide this one to get this one. And let's look at another example. So we've got the number 8 here. How do we get from 4 to 8? We multiply by 2. But then how do we get from 20 to 10? We divide by 2. So can you see, because my whole number has stayed the same, and so has my numerator, that when my denominator changes, you look for the relationship between the numbers, what has it been multiplied by, and then you do the opposite to find the answer. Now, we can also see this between 2 and 8. It doesn't just work with the next one up in the sequence. We can actually use this relationship to work out 2 and 8. To get from 2 to 8, we have to multiply by 4. Similarly, to divide by something, when we have 40 and 10, you divide by 4. So it's the inverse operation there. Okay, thinking of this diagram from the previous slide, if 1/4 of 112 is 28, can you work out the following? What is 1/8 of 112? What is 1/2 of 112? Can you pause the video and have a think? Okay, let's have a look at them on the screen here. So if 1/4 of 12 is 28, we are going to look and use the same rule as what we know before. So how do we get from 4 to 8? What do we need to multiply by 4 to get to 8? Yes, well done. We have to multiply it by 2. So are we going to multiply 28 by 2 to get this answer? No, because my denominator has changed, but my whole number and my numerator have stayed the same. I need to do the inverse. And what would that be? Absolutely, divide it by 2. What is 28 divided by 2? That's right, 14. Similarly, looking at 1/2 of 112 then, we could work out the relationship between 8 and 2. What do we have to divide 8 by to get to 2? How many 2's are there in 8? That's right, there are 4. We have to divide by 4. So then what do we do to this number? Do we divide by 4 again? No, we don't. We multiply it by 4, don't we? We multiply it by 4. So 14 multiplied by 4 is 56. And you can see the relationship there. I want you to work out the following to these questions and have a go if you can recognise the pattern. So pause the video and have a go, please. Okay, 1/6 of 12 then, we can work out 1/6 is 2. 1/6 of 24 is 4. And 1/6 of 48 is 8. Now, what do you notice? What's the same and what's changed? Pause the video, have a think. Okay, have you noticed that this time our denominators are the same? 1/6, 1/6, 1/6. In fact, the whole fraction is the same. But this time, our whole number is changing each time. Before, our denominator would stay the same and our whole number, our denominator would change and our whole number would stay the same. This time our whole number changes. Let's look at the relationship between 12 and 24. What do we multiply 12 by to get to 24? Absolutely, we multiply it by 2. And how do we get from 2 to 4? We multiply it by 2. So we can agree that when the fractions are the same, the whole number, whatever the whole number is multiplied by, so if it's 2, the answer can be multiplied by 2 as well. Similarly here, with 48 and 8. We know to get from 12 from 48, we can multiply it by 4. So 2 multiplied by 4 gives us 8. Having this information, if 1/3 of 21 is 7, can you use this information to work out 1/3 of 63 or 1/3 of 210? Pause the video and have a think about these following questions, please. Have a go. Okay, so if you know that our fractions are staying the same, we can work out the relationship between 21 and 63. We know that to get from 21 to 63, what do we have to multiply by? 3, well done. So we have to multiply 7 by 3 to get 21. Similarly here, we know that to get from 63 to 210, we can't really do anything. So we can use 21 to get to 210 by multiplying by 10. So then 7 multiplied by 10 would give us 70. Now, the final part of today's lesson before you have your own go, we're going to look at one final clue. So we've already found out that if the fraction stays the same, then whatever we do to the whole number, we do the same to the answer. But if the denominator changes, whatever we do to the whole number, we have to do the inverse. Sorry, whatever we do to the fraction, we need to do the inverse to the answer. And we're going to look at the theme and the rule for this one now. So pause the video, have a think. What is the answer? So what is the rule? Off you go. Okay, so if you think 1/5 of 25 is 5, 2/5 of 25 is 10, so 4/5 of 25 is 20. So what do you notice? What stayed the same and what's changed? Pause the video and have a think. Okay, so this time the whole number has stayed the same, the denominator has stayed the same, but my numerator has changed. Let's look at the relationship then. How do we get from 1 to 2? That's right, we times by 2. We multiply. So to get from 5 to 10, we multiply 2. So we are not doing any inverse. We only do the inverse for the first rule. And then to get from 1 to 4, we can multiply it by 4. Therefore, to get from 5 to our answer, we need to multiply it by 4 too to get 20. And having this information, if you know that 2/9 of 27 is 6, can you work out 4/9 of 27 and 8/9 of 27, but also 6/9 of 27? Pause the video, have a go. Okay, let's have a look then. So, if we know that 2/9 of 27 is 6, we know that to get from 2 to 4, we double. So we could double 6, which is 12. Similarly, to get from 4/9 of 27 to 8/9 of 27, we double the 4, we multiply it by 2. So we can multiply 12 by 2 to get 24 too. But this time we can't use the number 8 to get to 6. And we can't use the number 4 to get to 6. But we can use 2 to get to 6. And we would be timesing by 3. So that means we need to multiply 6 by 3, giving us 18. Can you have a go at questions 1 to 5 on the worksheet? Pause the video now, please. Off you go. Okay, the final part of this today's lesson is to decide whether you can compare each of these amounts as greater than, less than, or equal to. Pause the video and have a go. See if you can remember some of the clues and the rules from today's lesson. Off you go. Okay, how did you do? Did you work out that for the first one, they have the same whole number? They also have the same numerator. So we can see here, we can use a bar model to help us because they have different denominators. So we can have a bar model showing 2/5 and we can have a bar model showing 2/9. And we can see that 2/5 is actually greater, we can see here, than 2/9. And because the whole numbers are the same, this will apply for both of them. Number 2 then, 5/6 of 36 compared to 5/6 of 54. Well, we can see that the fractions are exactly the same, but the whole numbers have changed. And because 36 is a smaller or bigger number than 54, smaller, good job, that means that 5/6 of 36 is less than 5/6 of 54. Next one then, 3/4 of 20, half of 42. Let's work out half of 42 first then, because we can see that half of 40 is 20 and 42 is greater than 40. And then when we look at 3/4 of 20, we can see that half of 42 is greater than 20. But then when we're looking at the 3/4, we know that still applies. So 1/4 of 20 is less than half of 42. And you could have worked out what 1/4 of 20 was because that, 3/4, because that would be 15. And then 1/2 of 42 is 21. So yes, that's absolutely correct. Finally then, 2/3 of 15 compared to 1/3 of 30. And we can see, we can use the fact that the numerators are different and the denominators are the same. We can see that to get from 2 to 1, we divide by 2. Similarly, to get from 15 to 30, we do the inverse, we multiply by 2. We can then use a bar model to help us. So I can see that I've got 2/3 represented on my bar model here. If I wanted to look at 2/3 of 30, I would have to double that compared to 1/3 of 30, which actually means they are equal. So well done if you got those right. Can you have a go at the rest of the questions on the worksheet, please? Your final task for today then is to have a go at the reasoning and problem solving questions. You either need to choose the blue ones or the orange ones, which are slightly more challenging. Please don't do both. So the first one is all about making a cupcake recipe. She only needs 3 cupcakes, but this is a recipe for 4. So what do you need to do? And then we're looking at who is correct and explain how you know. Okay, have a lovely rest of your day, Year 4, and I will see you in our next lesson. Bye.